today we're joined by two special guests, Jennifer with Copeland and then Chris with Johnson Controls. This podcast focuses on Refrigerant Insights 365. And so I was just going to have Jennifer, if you wanted to go ahead and introduce yourself and tell us a little bit about your background. Go ahead.
Okay. Yeah. So I'm Jennifer Butsch with Copeland. I'm the Director of Regulatory Affairs there. I've been with the company about 8 years and am responsible for monitoring refrigerant policy as well as efficiency policy. So whether it's at the state or federal level, codes and standards, anything kind of affiliated with that space.
Great. Thank you for that introduction. And then Chris, if you wanted to go introduce yourself.
Thank you. Very similar to Jennifer, I do a lot of the same things. Started out as an engineer, design engineer, worked as a product manager for a long time, and then doing this full-time regulatory role since 2018. I got thrown into this full-time as part of the refrigerant transition, so I said somebody get up there and see if you can get California to align with something. So been working on it quite a while.
Okay, that's great. It's really a privilege to have you both on here today, and so I think we can definitely go into a broad overlook of like what's going on in terms of refrigerant policy for 2025. And so I guess with that, I'll start with the first question, which where are we today in terms of refrigerants?
Yeah, so we little over a month now, we've transitioned for the air conditioning unitary sector. They call it the stationary sector. It's residential like commercial, rooftops, some chillers. We as a manufacturer can no longer build products with 410A, right? So the limit's 700 GWP, but we'll talk in terms of refrigerant. So starting January 1st, we started production of our low GWP offering 454B for our ducted products, and then R32 that we import for our ductless products. So I think I've done a couple of these presentations here this week, and I was going to ask the audience a question about maybe how many of them have seen any new A2L equipment in the market yet? Anyone seen it? One? Couple? Yeah, I've been seeing a pretty small amount that are in the market. So there's still the channel using the old refrigerants for now. So.
Yeah, and then on the component side, we're still allowed to build 410A compressors for service. They have to be labeled for service only. We also have a new product rolling out with 454B and R32. You may not have seen that yet at your wholesalers and distributors quite yet, but it is on its way, so it should be there shortly.
Okay, that's great. Do we want to ask the question about the lead times with the audience as well?
Yeah, so I think coming out of COVID, there was always some issues on lead times, supply chain. I think everybody knew, there were some challenges there. The questions I get lately more around how's your lead times for the new product going to be? And I think if you look at some of the OEMs, I would call them more normal. I don't think they're what I would call pre-COVID levels, but they're better and getting better. And as we transition over, as the channel bleeds through the inventory of the old refrigerant, you'll see those continue, to improve. But I can tell you, we have quite a bit of inventory, as we normally would. Most of the OEMs are going to have inventory right now building up for the summer peak season, particularly on the residential side. So that's going well right now for us. We're just trying to digest that inventory of the old refrigerant is now, when that will happen, right, is kind of the unknown factor, which is somewhat weather dependent sometimes.
Okay, and so in terms of A2L allowances in the states, what are you hearing right now from the field in terms of AHJ issues or anything like that?
Yeah, because there's not been a lot of it there, it's more, I'll call it preemptive inquiries, although I will say there's been a couple. One from this state. It's an HJ, wasn't really familiar with A2Ls, hadn't seen the latest code updates for the state, so we've had a couple calls with the HJ, and so we were able to, I'd say, educate the HJ on the standards. And the challenge we have, right, is states adopt the codes at different intervals. So, in this state, they've done a pretty good job of keeping up with the codes, but the HJs aren't always on the latest as far as, hey, this is what happened January 1st. And some of the codes are really that recently updated, so I think a lot of it's educational, but I think we've got a tool or two, right?
Yeah, so AHRI released an interactive map. So if you are doing business, you can go into that map and click your state. It'll tell you if the building code's been updated or if they use legislation to allow A2L equipment. Basically, the legislation just said if the EPA allows for equipment to be built with a certain refrigerant, that the state building code can't prohibit it, so it's pretty straightforward. But AHJs aren't typically used to dealing with legislation, and so this is something new to them, and so probably why there is a little more concern on this transition versus, say, previous transitions, because as we are transitioning to different classifications of refrigerant, and we're using different processes that have been used in the past, it just, anytime there's a difference or a change significant like that, potential for the need for additional education and awareness.
Yeah, absolutely. That's a great tool. Again, like I just, right before this, I went and Googled it on my phone, so if you just do A2L code, AHRI A2L code map, it'll come up with both the U.S. and a Canada map now.
Yeah.
So we get Canada as well. So.
Has anyone had any issues in the field with HJs not approving an A2L install? No? Okay, that's good.
Yeah.
Oh, authority having jurisdiction? So it's usually the fire service, but it could be someone else in a municipality.
Okay, so as we all know, the new administration has a very different view in terms of climate policy. So is there any concern in terms of the AIM Act or other refrigerant regulations being rolled back at this point?
Yeah, I think we saw what happened day one with the president signing, I think, quite a few, executive orders. There were a few of those that would touch our industry. The thing about the executive orders is they have limited authority. Right? They can't just trump a law, so to speak, right?
Right.
But there's some things in there they're looking at our joining up. I think everyone's heard of the Paris Accord, right? We clearly are going to withdraw from that. That's more emissions. Refrigerant would be one part of that. It's not everything. What's bigger concern is, as far as specific to refrigerants, is what we call the Kigali Amendment. And an executive order by itself can't get us out of that because it takes Senate ratification and involvement. I think the bigger one is what they call the Congressional Review Act that got a couple bills going. That could stop part of the AIM Act that has to do more with refrigerant management. But I think in the sessions I did recently, and to your point, Elizabeth, is we're hearing, hey, the transition, this 1/1/2025 date is going to be rolled back. That's not in scope of the IRA that's being challenged by the CRA.
Yes, I would say in general, a lot of these refrigerant regulations have been challenged in court. So we've seen a lot of litigation over the years. So this isn't anything new to have some uncertainty with timing or if a particular rule is going to hold. But this administration definitely is taking a closer look at what they can do to pull some of this back. Now, if we think of the AIM Act in particular, which is guiding our refrigerant transition at the federal level, there's three EPA rulemakings that rolled out of that, and two of the three are probably more stable, and the third one, again, as mentioned by Chris, is subject to a Congressional Review Act at the moment, so that's the one that's probably most at risk today. But again, there's other litigation that was already in place under the previous administration, and so we're also carefully watching that. So, always something going on in D.C., I guess.
Right.
All the time.
Yeah. Okay, so question for the audience. Has anyone heard any rumors about refrigerant regulations being rolled back? And by a show of hands?
Anyone have any relatives in the new administration?
Okay.
If we do, see me outside.
Okay, let's switch our focus now to the state level in terms of refrigerant regulations. What's going on in the state of New York right now, Chris?
It's a mess, right?
Yeah.
So the challenge we've had with the AIM Act under the EPA, unlike DOE, is the EPA doesn't have federal preemption. And what that means basically is that when the federal government makes a regulation, if it has federal preemption, the states have to follow. Mm-hmm. That's not the case with EPA and refrigerants. So that's why you see states like New York, California, Washington State continuing to promulgate their own rules. And the situation in New York is they've taken more, I'd call it EU type approach, and come up with some very aggressive phase down schedules. And they're unique in the sense that they use different metrics than all the other regulations. And the rules were just, say what it is, not really well written, confusion. And I will say this, the GWP levels they've selected will require either codes and standards to change or an equipment type change from an air-to-air to an air-to-water system, which in the U.S., air-to-water is not very common. So we would like to see New York, we'd like to work with New York to update their regulation. And I would say there's been some pretty strong reaction from other organizations on that regulation, so there's more to come, I would say. And Jennifer, you've got something else to add?
Well, I would just say the challenge with the state regulations is that it leads to a lot of fragmentation. And so when we have this patchwork effect, there's always a concern that every state does it slightly differently. And so overall, there's 3 states really that regulate HFCs above and beyond the federal level: California, Washington, and New York. There's others that could do it in the future, but those are the 3 that are active today. And the New York regulation also has some requirements about reclaim usage in the future and record keeping and reporting. And so the concern becomes just, if you have retailers that have supermarkets in multiple states, now each state has a slightly different record keeping and reporting. It's a lot of administrative overhead, and obviously lots of concern around consumers and increased food costs, and all of that plays a part. So the more that we can just keep federal level regulation, the easier it is for us to design one level of equipment, right?
Right.
And keep the costs, better controlled. It's not perfectly within our domain, but to the extent that we can. And so California is also looking at an ultra-low GWP roadmap. It'll be published this summer, so TBD on if it is matching New York or something different. And people have asked us before, is there another phase down coming, or how long is this refrigerant going to last?
What's next?
And what's next? And so especially on that air conditioning, heat pump, chiller side, we know, or largely now we know with New York at least for sure, that 700 GWP is not going to hold forever. And so New York has now defined or put a line in the sand of when they're going to move to ultra-low GWP, which begs the question of, what's the next federal transition look like, or what does California and Washington do? So again, this fragmented approach does drive extra complexity, which drives increased cost. And so that's why it's a pretty large concern of OEMs and industry broadly.
Yeah, I'd say you don't want OEMs like ourselves making different products for different states, right? That would increase cost, decrease scale, increase cost, availability would go down, right? So we like uniform, to Jennifer's point, we don't like a patchwork of regulations. So that's where we spent a lot of years trying to get the states to voluntarily line up, which it's worked in most, but unfortunately not all. So.
Yeah. And if you're a contractor or a distributor or wholesaler that are close to a state line, that also introduces a lot of complexity for you, because now you have to keep track of what state the equipment's being installed in, not necessarily purchased in, and so a lot of complexity.
Yep.
Okay, and so we were talking about the GWP thresholds and heading towards ultra-low GWP. And so what are some of the primary concerns with that stakeholders should know about when they're headed towards some of that ultra-low GWP?
Well, yeah, I'd say that the first thing, all codes are local, right? So you need to, even though there's federal, there's state, there's city, and there's even some that go down to the government building level. So knowing your local codes and standards and what version they're on is pretty important. I'd also say that for the ultra-low, one of the lessons learned from this transition that happened just January 1st is that if the codes aren't in place, as we said, I could build a ultra-low unit, but if it has a different flammability class, an A3 like propane, couldn't put it in. Because there's charge level limits, right? And one of the things we did for the 2Ls is we had to do a lot of research with a lot of stakeholders, and that drove updates to the safety standards at UL and ASHRAE. and those get adopted. And what we learned from the 2Ls was if you try to get in front of that, right? Because there were some stakeholders that wanted this transition that just happened in 1/1/2025 to happen back in 1/1/2023. And they just got in front of the codes and standards process. So going to an ultra low, we don't want to make that same kind of mistake. And that will take time to go through the codes process. Even if EPA were to mandate in the case of New York as an example, New York could mandate it, but they don't have authority over the codes. So that's where we get into situations like we had to pass, as Jennifer mentioned, pass legislation. We would rather the codes and standards drive it than legislation. But if you get in a bind like we did this last time, right, that's why you have to have both. So.
Yeah, and I think from our perspective, too, when we design new products, there's kind of three key aspects to it, right? So we want to make sure the products are safe, first and foremost. Mm-hmm. We can't do something that's not safe. And then reliable. So we put a lot of focus on reliability. We do a ton of testing under various conditions to make sure this equipment's going to last for its useful life in the field. And then the third part would be consumer impact. So again, going back to that cost picture. And as we think about moving to ultra-low GWP, that's where a lot of these challenges come in place because the number of fluids available for us to use is significantly reduced. Less than 10 GWP20 gives us essentially 5 main commercialized fluids today. Doesn't mean that new fluids may not come on the market in the next few years. That is a possibility. But if today we look at the 3 that are mentioned quite often, are propane or 1234YF or CO2. And all of those 3, if we think about them, are significantly different. And if we just use air conditioning as a baseline for today, so 410A, 454B, R32, all very similar in capacity. If we go to CO2, it's significantly higher pressure, which would require a lot of cost. The components that can deal with CO2 are thicker, just more material in general, which drives up cost, not to mention mitigation of dealing with that pressure in extreme circumstances. If we think of propane, that's where that A3, that higher flammability comes in. Codes and standards don't allow for that to be installed today, so there's some work to be done there. Likely it's an indirect system, which means we're going to take an efficiency hit. Mm-hmm. So again, if you're going to match the efficiency of today's equipment, that's increased cost because you're going to have to actually make the equipment more efficient to deal with those efficiency losses that are inherent to an indirect system. And if we think of a YF, it's such a low pressure fluid. It's 134A-like. That's a big challenge because from a displacement standpoint and a compressor standpoint, it's going to likely be larger and it's going to likely require different heat exchangers and different parts throughout that system, which again are probably going to drive increased costs or a different footprint. And so if you think of our market, almost 85% is replacement. And it's like for like replacement typically. And so if we're locked into an existing infrastructure, footprint, whatever, and now we're bringing in equipment that looks significantly different or is a different architecture, that's a big challenge for replacement. Maybe not as much for new construction, but again, 85% of our market roughly is that replacement market. So it's something that we really care about. And on the commercial refrigeration side, we see similar challenges. You can't retrofit an A1 with an A2L. A lot of these refrigerant transitions are very disruptive to their business. In some cases, they have to shut the store down for a week, 2 weeks, however long it takes. And so these are really big investments being made. And these refrigerant transitions are very disruptive.
Yep.
Okay, that was. Thank you for going into that the complexity of the various challenges that would mean when we would do another transition. Yeah. And so.
Well, and it's something that I think regulators aren't always fully aware of. Like they just see the environmental benefits or they're given a law is passed. So if there's policy passed in a certain state of we're going to reduce our emissions by so much %, they just look at how they can achieve that. But there's a lot of practical implications on the back end that also need to be considered. And so that's where I think working together as an industry, we have to convey some of those challenges and barriers to the adoption. It's not like we're just trying to stop progression. We all innovate new products. That's in our DNA. Right. But there are some logistical challenges that timeline-wise or just equipment-wise need to be considered when they're rolling out these rules so that they are implementable, really. Because there's going to be some challenges in New York, as Chris mentioned, and so we'll see how this plays out in the next few years. But
one of the executive orders that was signed, it was the agencies were told to specifically look at cost to consumers. right? Some of these regulations are going to increase costs. I mean, that's just if they're not done right. So we, again, to Jennifer's point, you got to look at more than just efficiency, capacity, glide for service, right? If the refrigerant fractionates, would make service pretty hard, right? Even though it might work for me at the factory, if you had a leak, it would lose its blend ratio. So there's a lot of factors that go into the refrigerant. It's not just looking at one parameter, and that's what we're trying to educate some of these folks on is, hey, look broader than just your one, your one metric that you care about, because there's a lot of factors to choosing a refrigerant. So.
Right. Right. And do you want to go into any more detail about the cost of A3 systems?
Yeah, I mean, obviously the deal with A3s like propane, R290, is its flammability, right? Mm-hmm. That's far, far different than what we're going to today, A2Ls. The safety mitigation that we've just went to of the refrigerant detection systems likely will not be the same for an A3, right? Mm-hmm. And depending upon the type, as we said, if it's a direct system, it will be a very high safety factor. If that refrigerant can leak on an evaporator or on the indoor, be it a package or a split. Indirect, a lot of people think, well, if it's an indirect, you can put whatever you want outside. That's not correct. There will be limits on, like, spacing, right, parapet walls, ventilation, even outside. So there's going to be some constraints there. It won't be do whatever you want if you keep the propane outdoors. But as Jennifer mentioned, right, you still have DOE requirements to not backslide. That's a federal requirement. You can't go backwards, and that's going to be a hill to climb. You got an additional heat exchanger, you have a pump, and you have glycol, which itself is an impediment to heat transfer. So we're going to, there's no easy solution here, is what we're trying to tell folks as they lower that GWP.
Right.
A lot of factors to consider. So.
And Jennifer, do you want to add on to anything that he said about the cost of A3 systems?
Well, I think he covered it pretty well. I think it's just today the codes only allow 3 times LFL for an A3, regardless of where it's installed. If it's listed to UL 2-40, and that's 114 grams. There's only a handful of appliances that can run off 114 grams of propane, and so the first step is updating the safety standards, then updating the building codes, which we just went through for A2Ls, and it's not an easy lift. And so some of the dates in the New York regulation in particular are really challenging. I mean, residential water heating, that transition date is 2027. That's only close. 2 years away. And so there's not any products that I'm aware of on the market today that would meet that requirement. So that's a challenge. On the air conditioning side, 2034, and then there's a handful of products that are mostly aligned on 2034, but chillers are 2030, VRF I think might be 2030, so there's just a handful of products in there, and maybe it sounds like it's enough time for us to prepare, but there's a lot of challenges.
Well, I'll just say this, I don't think it's good policy to regulate on a hope that things will happen, right? There's a balance there of trying to be, I think some states call technology forcing. We want to force innovation, but if the innovation doesn't come, that could be a real disaster from a public policy perspective. So what we would prefer is let's do the research to start with, determine how that works into the safety standards, and then get that adopted by the states, and then get the codes and standards folks and the states all on the, all aligned. And that's, to me, the lesson learned of what we just went through.
Yeah. Okay. That's a great discussion on A3 systems. Does anyone have any questions so far?
None?
Anybody want to be a guinea pig for the first A3 system? All right.
Okay.
We got a question over here.
Oh, you're going to have to come close.
Yeah, you're going to have to come close.
Sorry, it's really loud. Do you think the president's going to...
Do I think the president's going to roll back? Is that the question?
The EPA?
I think he's going... What Jennifer and I were in a meeting this morning, right? Any regulation that's got the word climate or emissions in it will be looked at. Now, again, executive orders have limits on what they can do, right? There's things they can do. You can withdraw from the Paris Accord, but you can't just undo a DOE rule. That would take a new rulemaking. But is there a will to do rulemakings on that? Maybe. I think the most uncertain thing that we're understanding, and Jennifer mentioned it on the grocery side, there's been a lawsuit on another part of the AIM that the grocery association has brought, that would probably be the one that might pose the greatest risk. But we want to make it clear, like, for the transition that just happened, to try and reverse all those supply chains. If I, as a manufacturer, I go to Jennifer and say, Jennifer, you got to start making me all those 410A compressors you just phased out. And then I got to go to Sporlan and say, Sporlan, you got to make me all those valves, right? You guys in the market understand trying to turn that battleship around would be a very challenging. It would take years, right? So
and be costly. I mean, we've already made the
yeah.
investments to transition, and it doesn't make sense to go backwards. But subsection H, which is more on the reclaim and refrigerant management piece, that is under a Congressional Review Act, and so that one possibly could. Possibly could. Again, there were 3 rules under AIM Act. We kind of refer to it sometimes as a 3-legged stool, and so you know what happens if you have a 3-legged stool and you take one leg away, it kind of falls over. And so each of those 3 pieces serves a very specific piece, one on the supply side, so phasing down the supply of HFCs, and then 2 on the demand side. So the GWP limits talk about the demand of higher GWP refrigerants in new equipment, and then this reclaim and emissions reduction rule is really around how do you reduce the demand for HFCs in existing equipment. It's largely around leak prevention or record-keeping and reporting when you do have a leak to force you to essentially to fix it or repair it more quickly, so within 30 days. So if your equipment never leaks, obviously that reduces the demand for high GWP fluids. They don't want these systems out there just leaking and we're just constantly adding new refrigerant to them. And then the other side would be to use reclaim. So we have to bolster the amount of refrigerant that we're recovering, make that available back to a reclaimer so they can refine it back to the AHRI 700 level and then put it back on the market as reclaim. And so keeping that refrigerant cycle also reduces the amount of virgin refrigerant that we need to put in the market and helps reduce the quantity needed so we can really meet the supply quota.
I mean, a pound of reclaim uses a pound of new refrigerant that never gets produced. So that could leak, right?
Okay. And also, in your question?
So I'm going to try to repeat the question. So between an A2L air-to-air system and an A3 air-to-water repair parts related question? I mean, I don't know. You want to answer that? Like, you might give an example of your 410A consolidation.
Yeah. So the EPA allows for us to continue to make components to service existing equipment, so we don't have any restrictions on the amount of compressors, for example, that we can make that are with 410A. Well, maybe to your point, the more fragmented the market becomes, obviously the more complex your manufacturing lines, the more fragmented they become, the higher your cost is, your operating cost. And so, I think at some point that does definitely factor in. The more streamlined we can make it, the better. And so, on Copeland's side, we've recently announced our LXE line, so we're going to consolidate 410A compressor lines. We used to have K5, K6, so for service, we're going to consolidate that, and the number of SKUs will be reduced to help address that complexity problem, try to help keep the cost more manageable, and help the wholesalers really just have a more limited inventory so they don't have, hundreds of SKUs. Now they have 20 SKUs. Yeah. I don't think there's any concern in fulfilling the need, but to your point, the complexity does drive cost at some point, and so the more we can reduce that, the better.
I mean, and I would just say that's normal. When we went through these refrigerant transitions before, I think what I produced as an OEM, you look at the aftermarket, and the suppliers, right, they'll consolidate to try to do what Jennifer just said. So this is not new. This is kind of a normal thing. Where it gets a little bit different is if you try to change equipment types, which is part of your question, I think, about going from an air to air to air to water. There are no previous parts for air to water, right? There's no there's no heat exchanger sitting out there to take refrigerant to a glycol. There's no pump, right? So those would all be newly introduced, and they would add to the aftermarket, requirements. It'd be new, but you got to have service parts for any product you put out there. So it would add complexity. Yeah. And if you're in the aftermarket business, it's a good business opportunity, right? But I don't think what we like, and I'll go back to the fundamentals that Jennifer mentioned, is we don't like the patchwork. Like as an OEM, I don't want to make air conditioners just for New York, right? Or Massachusetts and a different one for the rest of the country, right? That's not good for manufacturing. It's not good for scale. It's not good for parts. So we'd like to have uniformity. So availability's best, right? Scale's best, cost is low. That's just kind of common blocking and tackling on, business. So that's the problem with the patchwork.
Right.
Yeah.
Yeah, and for those that are still sticking around, we do have some fun swag towards the end. So just letting you know that they brought some really cool swag along. So yeah. Do we want to touch base on PFAS a little bit, Jennifer?
We can.
Okay.
So when we talk about refrigerants in particular, PFAS comes up. It's per- and polyfluoroalkyl substances. It's really just a group of chemicals that it's a chemical family. It can be up to 14,000 chemicals depending on how it's defined, so it's a very broad group. Historically, PFOA and PFOS have caused health concerns, and so that's where, and that's very well documented, and so there are some harmful substances within this chemical family, and so there's a lot of debate and science and research going on right now to understand broadly 14,000 chemicals. We know a handful of them have been demonstrated to be harmful. How should we treat the whole chemical family? And so when we talk about refrigerants specifically, again, we go back to, as producers, we want to make sure our products are safe, reliable, and then we want to make sure we understand consumer impacts. And certainly safety and consumer impacts, health is a very important consideration. But to date, the harmful PFAS fall into one of four categories. They're either persistent, bioaccumulative, so they build up in your body, toxic, or mobile, so waterborne. They can be carried in streams and found in drinking water. Refrigerants inherently by themselves do not check any of those four boxes, okay? So the science shows they're not persistent, bioaccumulative, toxic, or mobile. The challenge is when they do leak and vent into the air, one of the byproducts of degradation, so as they break down over time, is TFA, trifluoroacetic acid, and that by itself is persistent, so it can accumulate in the environment. It's been found in the environment, and so there's some discussion of, does persistence alone is that enough risk to ban the chemical? And so we talked about some of the challenges with the ultra-low GWP refrigerants, and so we covered the challenges with propane and CO2, which would be largely PFAS-free. There's a handful of other chemicals that also would meet a PFAS-free definition. But this science continues to evolve, and I think the discussions are just that if we're forced to go PFAS, if there's really not evidence of risk, do we take a precautionary approach and ban all of the fluorinated gases and force us to a propane A3 system or a CO2 much higher cost system because, again, that pressure really high? Or do we continue to do research and, again, given that some of these chemicals are used in inhalers today and things that are really injected into your body, and of course refrigerant, I hope no one's drinking refrigerant, So if the risk is less, going back to the safety and reliability, it's kind of that risk-based approach, right? We just want it to be rooted in science. And so I would say the leading agency on this is UNEP, the United Nations Environmental Program. And so to date, they've come out and said that refrigerants do not present enough risk to regulate them or eliminate them at this time. But that, again, that research and that science is still evolving. And so we continue to monitor that very closely.
Yeah. Covered it well.
Thank you. Okay, thank you for that. I appreciate that. That was a very detailed response. But
I think to highlight, you're going to have a different viewpoint on PFAS later. So
I will.
Yeah.
Yes.
So Mark will join you later, and he'll present his view on that.
Yes. Yeah. We will be in Podcast Pavilion 2 at 5. 5 o'clock, I think, to talk more about like natural refrigerants. So that will be an interesting, leading to that. So thanks. Okay, so we're going to go a little bit into Canada, like if you guys want talk about.
So I was going to ask your audience, Canadians out there doing business in Canada?
Okay.
Couple?
Good.
Okay. There's a few out there.
There's a few, yeah.
Yeah, so, talking international here, the first thing I'll say is Canada, I know we're not talking tariffs where we're not in a line, but we're also not in a line on refrigerant transition. So Canada does not have its complete version of AIM. They have some sector bans on some chillers and some other refrigeration products, but they don't have a 1/1/2025 date like for residential, like commercial. So what that means is 410A can still be produced, imported into Canada, and it's not allowed here in the U.S. Current production now. So we've got a little bit of challenge with Canada, and I'll call it misalignment there. We don't know when they might do that. They've got their own regulatory process called AHR. It stands for ozone depleting substance something. I can't remember it all. I was just in Toronto a couple weeks ago, and if you're doing business on the border with Canada, it's a pretty long border. There may be a little bit of gamesmanship there. So what we traditionally try to do with Canada, be it efficiency or refrigerants, is try to get alignment. That just makes it better for both countries. Not unlike the tariff thing, and I'm not going to go into that, but we would like to see Canada come along and get in a line and not create any, I call it, cross-border shenanigans there. And I think we'll see some of that officially because you guys know the Montreal Protocol. It's named after a town in Canada. So it would make sense for them to hurry up. So if you've got any relatives in the Canadian government, tell them to hurry up. But we want our Canadian neighbors to be in alignment.
So even though there's not the requirement to transition to a lower GWP or a 700, it doesn't prevent them from installing equipment that has an A2L fluid in it. What would it prevent that, however, are the building codes. And so we've had some challenges. We talked a little bit earlier about the patchwork of building codes in the U.S. It's state by state or in some cases municipal. Provincial codes up in Canada, and they were behind where we were in the transition because their standards were not updated on the same schedule as ours, so they lagged. And so most of the provinces at this point have updated their safety codes or have a letter in place that says it's okay to install the equipment. I'm aware of 2, I think, that we're still waiting on.
I mean, they've got indication. I think if we talk to the Canadian guys, it's pretty imminent, they think.
Yeah.
But I have also heard that they're running into more of their AHJ problems up there. Had a meeting with one of our Canadian distributors yesterday, and they're like, they've got some real challenges with their AHJs. And I'll plug the AHRI A2L code map for Canada that's out there now, too. So.
Okay. Anyone in the audience, are you planning on continuing to supply 410A or 134A to Canada?
No. Okay. Shouldn't be any problems then.
Okay. We're now transitioning into our sustainability initiatives part of this discussion. So we're really looking kind of like a broad overview about how refrigerant policy impacts sustainability and initiatives. And so, Chris, did you want to go into some detail about how, what's going on with the sustainability initiatives in the state level?
Yeah, well, just in general, when you talk about that, a lot of states, New York, California, I think Maryland had one recently, they have broader, call it sustainability goals, where they're basically going to deal with carbon emissions. Refrigerants is one component of that. There's EVs and other things, but if we stick to the refrigerant tie, right, this is where, again, California, the reason California started their own, New York, Washington State, I think you're going to see that continue. When you remember, refrigerants are just one part of the overall emissions scope of these what they call them state implementation plans. So, as a company and through our trade orgs, we try to weigh in and make sure that what they're doing makes sense, it's feasible in that regard. But I think, with us transitioning now into the largest part of the market, residential like commercial, right? Last year we put in over 9 million new systems. So getting those all switched over to a lower GWP will certainly help towards that goal in that regard. So,
Yeah, another aspect of sustainability would be the individual goals that retailers and OEMs have and how it drives their purchasing behavior. So again, it's retrofitting where you can to a lower GWP of existing equipment, or at time of replacement, making sure you're selecting the lowest GWP that meets your needs. And so there's a few different considerations there on what type of equipment you might use and what fluids those might have, especially on the commercial refrigeration side. There are trade-offs. So when we talk about these larger systems, CO2 is becoming a lot more popular, especially for those large retailers that are national and have sustainability goals or net zero by 2040. So it is really driving a lot of those purchasing decisions. But those CO2 systems are more costly and more complex, like at least higher first cost, maybe operating cost over time, depending on the system, may even out. But so we are really having a lot of those discussions with retailers to understand what are their goals, what are the equipment options, and what are the trade-offs of those equipments. And so thinking about it from both CapEx and OpEx and trying to make sure that we're really helping provide that data that drives their best decision long term.
Yeah, and I just mentioned, you can't say sustainability is out these days without saying heat pumps, right? Mm-hmm. So the thing about heat pumps, we all love them, but they use more refrigerant. So if you think about the transition from straight cooling to heat pumps, that will drive additional refrigerant use. Now, there's technology changes. We can go to smaller diameter coils and try to manage that. But at the same time, trying to balance both of those initiatives from a sustainability, it's like a lot of engineering problems. There's always trade-offs. So as we transition some of these markets a lot faster than others to heat pumps, you also risk of increasing, emissions from the refrigerant side at the same time. So a lot of things you got to balance there.
Okay, well, and that's a good broad overview of the refrigerant policy outlook for 2025. Thank you guys so much for joining us. We're going to be posting this on YouTube and Spotify, so you can find my podcast at Refrigerant365 on social media, and we should have that published sometime in early March. Do we want to give away the swag?
Yeah. How are we going to do this?
I don't know what it is.
What's the method for giving away the swag?
You don't have, is there only a little bit of swag?
Yeah, well.
Maybe we can just set it back on the table and they can pick it up. So
like
back there on the table with our friends at AHR and Hardy, there will be a few things on the table. You guys feel free to stop by and take it.
Okay.
Because we're not taking it back. So.
Yeah, we're not taking it back.
Yeah.
Do you guys want to say anything about how people could keep up with you guys, or how they could learn more about what is going on with Copeland and
so I'm on LinkedIn. I'm happy to have you follow me. Copeland's on LinkedIn. We're on Facebook. We have social media platforms. We also have an E360 website. It's called the E360 Hub. We put out webinars and lots of information, not only on components, but also on just environmental topics. You might find that informative. And then just real quick before I sign off, I want to say, just summarize that at the federal level, I think we definitely expect a slowdown with this administration, which likely leads to an increased amount of activity at the state level. And again, our concern with that isn't necessarily that the states are taking the lead, but it just leads to potential fragmentation. And so that becomes a big challenge. So thank you. I echo everything Elizabeth said. We appreciate you joining us today.
Thank you, guys. Until next time, stay cool.
Thank you.